Hello everyone. So here we have to find out the partial fraction of the given fraction. Now if you will observe the given fraction, then you might say that here the denominator is in quadratic form, so we will be applying the quadratic factor method to find out the partial fraction. But let me tell you friends that here we are gonna use the method of distinct linear factors. Now you must be thinking that where is the linear factor, because here the factors are the quadratic factors. But if you will observe the carefully, then here all the terms in the denominator as well as in the numerator are x square. So whenever in the fraction all the terms are similar, let's say the x square or x cube or something like that, then we can substitute it by a variable, let's say t, and this method is called as distinguished method of partial fraction. So here I am gonna use the distinguished method of partial fraction. So by distinguished method we substitute this similar term by some linear term t. So here I will say consider x square as t. So by considering x square as t, this fraction will become, that means x square upon x square plus 1 x square plus 2 will become t upon t plus 1 t plus 2. And now if you will observe, then you will say yes, it is linear factor in the denominator. So let's apply the method of linear factors, and after finding the answer we will again resubstitute t as x square. So therefore here I will say by partial fraction we will say let t upon t plus 1 t plus 2 is equal to a upon t plus 1 plus b upon t plus 2, and I will say this as equation number 1. Now we will solve this equation number 1 by substituting different values of t, and we will find out a and b, where we will substitute this a and b here in the equation 1 to get the partial fraction of the term. So for that we will take the LCM on right hand side, and the LCM will be t plus 1 and t plus 2. By cross multiplication we will get a into t plus 2 plus b into t plus 1, and here we will get t upon t plus 1 and t plus 2. Now we can cancel t plus 1 and t plus 2 from the denominator of left hand side and right hand side. So therefore we will get t equal to a into t plus 2 plus b into t plus 1, and I will say this as equation number 2. Now we will substitute different values of t in equation number 2 to get the value of a and b. So let's apply the trick. So by the trick, whenever we want to find out the value of a, we assume the denominator of a as 0. So here I will assume t plus 1 as 0. So by assuming this t plus 1 as 0, we will get t as minus 1. So now we will substitute t equal to minus 1 in equation number 2 to get the value of a. So here I will say put t as equal to minus 1 in equation number 2. So here we will get minus 1 is equal to a into minus 1 plus 2, and if you will observe here, then minus 1 plus 1 is 0, so we got b as 0. So therefore minus 1 is equal to, this will become minus 2 plus 2, minus 1 plus 2, that is 1. So a, or I will say a is equal to minus 1. So we got the value of a. Now to find out the value of b, we will assume the denominator of b as 0, that is t plus 2 as 0, by which we will get t as minus 2. So now we'll substitute t equal to minus 2 in the equation number 2 to get the value of b. So here we'll say put t equal to minus 2 in equation number 2. So we'll get minus 2 is equal to, now see here, minus 2 plus 2 is 0. So the first term is 0. Here we'll get b into minus 2 plus 1. So therefore minus 2 is equal to, minus 2 plus 1 is minus 1. So it will become minus b, or we'll say b is equal to 2. So we got value of b as 2 and a as minus 1. Now we'll substitute these values in equation number 1 to get the final answer. So here I'll say substituting values of a and b in equation number 1. So the equation number 1 is this, t upon t plus 1 t plus 2. So this will become t upon t plus 1 t plus 2 equal to a upon t plus 1 plus b upon t plus 2. So a is minus 1. So minus 1 upon t plus 1 plus b, that is 2 upon t plus 2. So here we got the partial fraction for the given linear fraction. But let me tell you my friends that we got the answer in terms of t, but if you'll see the question, it is in terms of x square, or if it is in terms of x. So we have to bring our answer in terms of x, and for that we'll substitute t as x square. So here we will get, therefore putting t equal to x square, we will get x square upon x square plus 1 x square plus 2 equal to minus 1 upon x square plus 1 plus 2 upon x square plus 2. So this is the partial fraction of the given fraction. So here we have seen the distinguished method to find out the partial fraction of the given term. Thank you.